Welcome to Unit 3, Ratios, Proportions, and Percents. This little segment here will be split into two components. One component, the basic stuff, which if you already have a firm grasp of ratios and proportions, especially ratios, you can just skip and just go on to the applications module, which is the second part of this two-part series, broadcasting to you from the Wesley Bunker, way in suburban Edmonton. Let's do Unit 3, Ratios, Proportions, and Percents. And as with every unit that we have, we'll start off with some unit objectives and then move on to some terminology. Without the language, we don't know what's going on, okay? So we're going to use ratios and proportions to solve what's called allocation and equivalence problems. How do we organize our resources, essentially, in order to scale up our production process or to scale up our business or to scale it down? Okay? We're going to convert those percentages and common fractions and decimals. And we work in two worlds when you're in business. You both have to realize that we have to do the mathematics component of everything. We do have to do the calculations. Numbers and measurements are very important to us, but we also recognize that our clientele doesn't, necessarily deal with at the same mathematical level that we do. And so often we're converting those things into percents because percents are easier to explain. It's easier for people to understand percents and so on. So we use proportions when we actually doing the calculations, but often we report percents because that's what our clients and stakeholders understand. Okay? And then we'll look at rates and original quantities for increases and decreases. And this is important. We're talking sales growth, cost changes, stock market or stock portfolio evaluation, and so on. And now in later we get into the really important stuff, okay? So this unit, we deal with the basics in this clip, but it's the applications that are important to us. And one of the most important applications is converting currency. Okay? We as Canadians are very aware and in tune with how the Canadian dollar is valued relative to its American counterpart, right? So we're used to doing that calculation. It's reported in the media regularly. It's a common metric. If you watch BNN, you'll see it up on the right-hand side of the screen, and so on. Okay? So very important to us. But there are other index numbers that are important to us too. There's the stock market index. There's the consumer price index, and the list goes on from there. But really, once you've got the foundational stuff from our first 4 unit objectives, the next 2 are just applications of those techniques. So we'll do currency conversions together, but how you do currency conversions and how you do the index numbers, and including stock market indexes and CPI and so on, PPI, and this I and that I, it's just applications of existing knowledge. There's nothing new there. Okay, so what is a ratio? Now, a ratio beyond the fact that, hey, on Twitter, you just got ratioed, is it just a comparison, right? Which is what it is on that Twitter when you just got ratioed, of relative values of numbers and quantities. So it's relative. It's a comparison. So comparison of a couple of values, at least 2. Okay. We see this a lot. Price earnings ratio, which is a PE ratio. And that's just the ratio of the per share price of a company relative to its per share annual earnings. Very, very common ratio. In accounting as well as in finance, the debt to equity ratio is important. And that's just the total liabilities compared to or divided by shareholder equity. So there's lots of ratios. There's a quick ratio. And as you take accounting, accountants love ratios. Okay, they got ratios for everything. Okay. So we see ratios a lot, and we want to be able to understand them and go, oh, yeah, okay, ooh, you know, Apple's got a PE earnings of 33 and a half. What does that mean, right? It means their stock price per share is 33 times their per share earnings. Right? CIBC, it's about 10 and a half, right? And we can then make the analysis thereof, okay? So when we start talking about those ratios, what do we mean? Because we could represent ratios in a whole bunch of different ways, right? We're not limited, right? One way to represent ratios is 5-2. That's like odds. Hey, what's the odds that the mighty Las Vegas Golden Knights will win the Stanley Cup? Yeah, I don't know what it is, but we can represent that as such. Or what's the odds that the wonderful San Francisco 49ers will win the Super Bowl, if there is a Super Bowl? Okay. Ratios can also be represented by putting a colon in front of the two numbers. Okay. It can be represented as a divided by symbol. Right? Division, a numerator divided by a denominator, that's just a ratio. What's the ratio comparison of two or more values? Well, that's what dividing by represents. A decimal, such as 2.5, which is just taking that fraction and converting it into a decimal number, or a percent, 250%. 5 is 250% more than 2. Right? When the stock traded at 2, it went up to 5. Ooh, now it's 250% of what it once was. There you go. Everything right there in that one slide, we've pretty much labeled 80% of this unit. Now, when we do those comparisons, often just as a measure of convention and ease, if there's units, we drop the units. So as you can kind of see in the example on the PowerPoint slides, where we normally have 5 kilograms to 3 kilograms to 2 kilograms, just so that we're not cluttering things and making things a horrible mess when we do our calculations, or when we represent these things, we just go 5:3:2. Okay. The numbers in those ratios are called the terms of the ratio. And there's our terminology. A little bit extra here. So the procedure used to reduce ratios to lowest terms, okay, is the same as to reduce fractions to lowest terms. So same kind of idea. And you remember doing that way back, for some perhaps in elementary school. Okay, so let's do one of the problems. I'm going to do question B and leave question A as a question for you. Question B here. So we have the ratio 96 to 144 to 48. Now we want to reduce that, just like we're reducing fraction. Right? So we think of, what can I divide all three numbers by? Now, stopgap, you see that they're all three are even. You can go, oh, divide by 2. And that's fine. That's fine. We start off somewhere, and that's cool. But I kind of see, ooh, could be 2, could be 4. So let's divide that by 4. And I punch in through my calculator, and I get 24 to 36 to 12. And then I go a little bit more, those all look like they're divisible by 12. So let's then divide by 12. I get 2 to 3 to 1. All set, easy as that. Next thing idea there, or thing that we encounter in ratios is, how do I deal with ratios that have decimals in them? Okay, so the example here is 1.25 to 3.75 to 7.5. And the first thing we like to do is get rid of the decimal. It's the same kind of idea when we will encounter fractions in a ratio. First thing, get rid of the fractions. Somewhat awkward to work with. You can work with it. I mean, you can divide by a decimal number. It's not really a big deal. It's not impossible, but it's awkward and prone to error. So when we have that 1.25 to 3.75 to 7.5, first thing, get rid of those decimals, multiply everybody by 100. I get 125 to 375 to 750. Okay. At this point now I can do my regular factoring just like we did with the previous example. So here I can divide, you know, the example kind of goes, oh, hey, I commonly, factor by 125, so I automatically see that. But if you're not quite that way, you could look at that and say, you know what, $125, that's like $1.25. $3.75, $3.75. 7.5, that's like $7.50. Well, if I think of it like money, I could have divided these things by a quarter or 25. Then I got 5. Then I got 15, 5, 15, and bunch more for $7.50. So I could easily have divided it by 25, just recognizing that if that were money, dividing by 25 seems to jump out at me. And then go the next step, you'd see that they're also then each divisible by 5 after that. Okay, so if you don't see it right away, or you can say, you know what, those all look like they divide by 5. I start off with 5. And then I just go through that process again. So it's not like really the way to do it. It's the way that you find the most comfortable that works in these particular cases. For some, they jump right into 125. Some others start off with 5, see what happens, and just work it through like that. Okay. So let's say we're now, at the beginning, we said, hey, one of the things we could do with ratios is we could allocate resources, or we could allocate things. So let's deal with this situation here. We've got 968 parts. And we want to divide them up to 2 processes, or to 2 factories, or to 2 warehouses, whatever the case may be, on a ratio of 5 to 3. Okay. And so there's 2 different ways to do that. There's one, for lack of a better term, called my method A. And we just say, okay, so every time we allocate something, we're allocating 8 parts, right? 5 parts to one, 3 parts to the other. Okay, so the ratio 5 to 3 just tells us that 5 go to factory A, 3 go to factory B. I'm allocating a total of 8 parts. Okay. Then I value, well, how many of the 968, how many times am I really going to be allocating these 8 parts? And so I go 968 divided by 8, and I go 121. Okay. And then that tells us, okay, so 5 parts or 5 portions of these 21 things go to warehouse A. So 5 times 21 is 605. And then for every 5 that go to warehouse A, 3 go warehouse B, and that's 121 values, and you get 363. If that appeals to you, that's great. I find that a little clunky. I'm explaining it here, and I'm going, I get it mathematically. Conceptually, it just seems like a lot of work to me. So method B, I think most find method B just a little easier to work with. I still start off with the, hey, I have 8 parts. I got these 8 parts, 5 of which go to warehouse A, 3 of which go to warehouse B. So 5/8 of the total then. So 5 out of the total of 8 must then go to warehouse A, and 3/8 of the total, right, must go to warehouse B. So I go 5/8 times by however much I'm sending off, which is 968 in this case, and I get 605 go to warehouse A, and I do the same thing for warehouse B. It seems conceptually and intuitively a lot easier to work with, but again, as you can kind of see, they both result in the same answer, so it's not really a big deal. Okay, so let's give you a couple of questions here, and we'll see if this basic idea has taken hold or not. Proportions. When 2 ratios are equal, they form a proportion. And this concept, extremely important when we start to solve for currency conversions, dealing with index numbers, and so on. So this is very, very important stuff. Not super hard stuff, but extremely important. So for instance, this statement is just basically saying that the ratio of 3 to 4 is the same as the ratio of 6 to 8. So 3 divided by 4 is equal to 6 divided by 8. Well, yeah, that makes sense, because if I multiply 2 times 3 and 2 times 4, I get 6 divided by 8, right? So same as multiplying 3/4 by 2 over 2, which is 3/4 times 1, but 6 to 8, 3/4. It's the same. Okay. So we start off with that basic concept. Now, what if one of the numbers is unknown to us? So, for instance, we may have we may have looked on the markets and noticed that the Canadian dollar is trading at a certain ratio to the American dollar. So that is known. And then I further think, okay, well, let's say I want to convert $15 Canadian into its equivalent American amount. Now, I don't know how much that is, but I have this ratio from the foreign exchange markets that I can then use to apply to my conversion of that $15 Canadian into American funds. That American funds part, that's the unknown that I want to solve for. But the ratio of American dollars I get to Canadian dollars, so the ratio of American dollars to my 15 Canadian dollars, is the same as the ratio in the market of American dollars to Canadian dollars. Okay? And that's where we get into this little this third bullet, and the X is unknown. Okay? Now, we also remember from the early part of Unit 3 is that ratio, the colon, is nothing more than a divide by symbol. Okay? So we could also look at ratios in how they're equal by expressing them as fractions. So 4 divided by 3 could be the same as 12 over x. What is x? Okay, and then you have it in generic letters. Okay. Now, when we have it expressed as fractions, that's both convenient and inconvenient. It's convenient in that we're starting to express these ratios in mathematical symbology that we can do operations on. It's inconvenient because, it's a fraction, right? So one of the all-purpose best ways to get rid of that fraction, and so that we have a relationship or an equation that's very easy to solve, is to cross-multiply. Okay? So when faced with two fractions that are equal to each other, cross-multiplication is sort of our default go-to tool. And so, for instance, when we start off with that 4 divided by 3, ratioed or equal to 12 divided by x, if we cross multiply, we get 4x equals to 36. Well, that's pretty easy to solve. We isolate the x by dividing both sides by 4. We get that x equals to 9. Okay, no problems, right? And that is just classic way that we deal with currency conversions. Nothing more complicated than that. So let's do a problem together here, and it's an allocation problem, or an allocation-like problem. And we have the situation where we're manufacturing Gorilla Glass, and it requires $115 of supervision costs for every $96 of labor costs. So we kind of see a ratio there. Okay? At the same rate, okay, so we're going to use that ratio. How much supervision cost should be budgeted for 24,000 labor hours? How much supervision cost? That is the thing we do not know that we really want to know. That is our unknown. We're going to use the ratio specified in the first sentence to help us solve for how much supervision cost will be when we have 24,000 labor hours. Now, I'm going to do this a certain way that my experience has shown me that students respond very well to it. There are many different ways to do this problem, and with a lot of problems that we deal with, there's always going to be multiple journeys to the same solution. Hate to sound all philosophical here. So I'll show you one way that I found is easiest to explain, easiest for students to work with. So I'm going to keep things organized in columns. This also kind of makes the currency conversions easier to deal with, because in the currency conversions, we may be doing calculations based on currency relationships with which we are not that familiar. Okay, so let us break this down into cost. I'm going to have one column for cost, and I'm going to have one column for labor hours. Okay, so I'm going to have two columns there. Now I look at my relationship and I see that the cost is $115 and it's for every 96 labor hours. And then in the second sentence is how much supervision costs. So clearly I don't know what that is. And the ratio to that will be to 24,000 labor hours. Now I can easily express this as ratios being equal to each other. This ratio is going to be the same as that ratio. You could have turned it around and said that this ratio, the ratio of 115 to 96, is the same as x to 24,000, right? And that would just mean cost would be along a row, labor would be along another row. Okay. This is just one way of doing it. I think I find it's easy. After that, we got this pesky little fraction, and we cross multiply. We get 96x equals to 115 times by 24,000. We multiply that all through, and then we're able to solve for x. And x, as we've calculated, $28,750. So not hard. The thing is, you want to stay organized. You stay organized, the problems are actually fairly easy. Okay, and that's so important, because when you're dealing with exams, you're in a pressure situation, or you're in a meeting and everyone's looking at you. Hey, Alan, so we're scaling up our operations. We think the ratio of these kinds of costs is going to be the same. What do you figure this is going to? What's going to happen here? What's our total cost going to be? And you're going to want to be able to scramble this really quickly on the fly. And a pressure situation, just like an exam. And if you keep everything organized and everything is all sorted, the problem really does just kind of flow naturally. Okay, so basic percentage problem. I'm going to introduce some terminology, but really we don't want to get too deep into the formulas that you'll see here. The relationships are really intuitive. And things are much easier to understand and much easier to retain if we sort of keep that intuitive relationship in our mind and not necessarily have to race for formulas all the time. There will be certain cases where there'll be established formulas that are easy and efficient to refer to, and we'll go to our mathematical toolbox and we'll pull out those equations and those relationships. But for many problems, we sort of want to work with an intuitive sense for how the relationship works and how the relationship operates. Okay, so we have 25% of 80. Now, whenever we're converting, we're dealing with an operation with percentages, we want to convert that into a proportion, and so 25% becomes 0.25. 0.25 times by 80, it gives us 20, and that's the result. Okay. I think the wording is easier just to start with as 80 as being the original number and 20 as being the new number. Okay. Some textbooks call that 20 a percentage. I think just calling it the generic new number is easier. Right? So, I don't want to get too much into specific terminology that may be used by one group or another. Okay. 25% is called the rate. Okay? And we'll come to know that rate as growth rates, discount rates, interest rates. Okay, and it, although when we look at that bullet, 25% of 80 is 0.25 times. Well, yeah, of course it is. right? But, you know, we'll get involved. We'll start doing compound interest problems, and sometimes it can be something that gets missed. Okay, 80 is called the base. The original number, as we know, 20 is the new number. There is a formula there, but, you know, we're kind of intuitively tied into being able to work with this kind of issue. Right? When setting up, we can rearrange that formula, and a lot of textbooks try to work with the rearranging, but we don't necessarily need to worry about remembering a whole selection of formulas. Right? Once we know the original equation, along with some of our basic algebra skills, this stuff is, you know, we can fix it later, right? We can plug in the numbers into any equation and do a little bit of algebraic manipulation and get a resultant answer. So we don't need to worry about remembering or keeping track of a whole bunch of different formulas that really describe the same relationship. Okay? And besides, when I look at that and I look at the rate is nothing more than the mark on your exam. Right? And you say, what's the new number? Well, that's how many I got right. What's the original number? Well, that's how many I could have got right. And you look at the two and you divide one by the other, convert it into a percentage, you get the mark on your exam, right? And you've been doing this forever, right? So this is not new stuff. So we don't need to make it seem hard because we're in university. Again, rearranging the formula, and I only show this to you because a lot of textbooks kind of, you know, want to do this, rearranging the formulas a million times, and I just think it just adds to a whole bunch of clutter, mathematical clutter. Okay, let's do some practice problems. All right, first practice problem, problem A. On Friday, November 29, 2019, H&R REIT. REIT stands for Real Estate Investment Trust. A REIT is a nice investment option for investing in, well, of course, real estate. It's got certain potential tax advantages depending on whether you have it in, if you have it in RSP, registered retirement savings plan, or a TFSA, tax-free savings account. A REIT, investment trust, can be very, very useful in those particular vessels. Okay. So again, it's a way of investing in real estate so that you have a portfolio of properties. So this H&R REIT traded at $21.58. By May 26, 2020, it had fallen to $10.76. Ouch. COVID-19 really did a number on this particular REIT. What percentage of the original price did H&R REIT sell for on May 26, 2020? So we don't even need to really worry about formulas if we just sort of kind of intuitively understand how the English relationship translates into math. Okay, so I look at what percentage, okay, so that's what I want to know that I don't want to know, okay, of the original price. Well, that is just saying based on the original price of $21.58, right? So it's in the base, or it's in the bottom. Of the original price, did it sell for? So there's the new number. So new number divided by old number. And when I take that new number divided by old number, I get 0.4986. And when I convert that into a percentage, 49.86%. Okay. Often we convert it to a percentage because that's just easier to explain to stakeholders and understand. Okay. I'm going to focus in next on question C and question D, and to be, really zero in on the wording difference between C and D. And again, if we just kind of flow with the English and translate it into mathematical speak, a lot of the formulas that you'll see in this particular unit are very intuitive, right? You don't have to worry about memorizing them because you're intuitively tied into how they work. So 250% of what amount is 300? Of what amount? Of is just not like another way of saying multiply. Okay. 250%, we express that as a number, right? So 250 divided by 100, because you can't work with percentages when we're in an equation. Of what amount? So multiplied by some amount. Well, what amount? I don't know what amount. So that must be the unknown is, and it equals to 300. After that, this is pretty straightforward, right? I isolate the x by dividing both sides by 2.5, and I get x about 120 bucks, $120. Okay. Look at D. D is a 250% increase. Ooh, that means I'm adding stuff, right? Remember way back to unit number 2. I'm adding 2.5 in some number, so I must multiply it by that number. But it's an increase. It's an increase. So I must have started with something. Oh, I started with that number, right? And then is 300. Gather up the like terms. 3.5x equals to 300. Isolate x again, just like we did before, by dividing both sides by 3.5. And I get 75.714. There we go, right? So again, you know, we could race to the formulas, and we could try to memorize all that stuff, or we could just really understand the technique of reading the question and how to convert that question into mathematical relationships. Let's do part E as the end. The Canada Pension Plan premium deducted from an employee's gross wages was $53.46. Okay, so that's how much we took off. So it's kind of telling us that's on one side of the equation. And then when I read the second sentence is really telling me how that $53.46 was determined, which is just another way of saying what's on the other side of that equal sign. If the premium is 5.25% of gross wages, how much were gross wages? Okay, so I really want to know what gross wages are. So let's make that W. And I express the 5.25% as a proportion, so I can use it in a formula. W. Right? And then again, just like we were doing before, we're going to isolate W by dividing both sides of this equation by 0.0525, and we get the W is just a little more than $1,000. Okay. So not too bad, and not terribly painful either. Okay, so now we have problems involving increase or decrease. This is not really super new stuff. We've actually played around with this in our experience in Unit 2. We just actually did one question that really involves this type of relationship, and that's part D up here, right? So it just means the new number is the number you started with plus however much it went up or however much it went down. Okay, fine. Right? Not that hard. Right? Now, how do you determine how much it goes up or how much you determine how much it goes up? That could be involved. That could be complicated. But at a high level, it's very intuitive. Very intuitive. So let's look at a couple of questions here. And both these questions are not that hard. Neither one is particularly difficult. Okay. So I have question A. Amazon stock closing price on June the 2nd, 2020 was $2,472.41. Martha Money, analyst with Big Bucks Analytics, projects that Amazon stock price will increase by 25% by December 30th, 2020. So far in 2020, Amazon has done quite nicely. What would be the dollar increase in Amazon stock? Dollar increase, right? Well, it increases at the rate of 25%. 25% based on what? Well, 25% based on the original stock price. So 0.25 times by 2472.41. Oops, make that look more like a 1. And what do we end up with? $618.10. Okay, that's how much the increase is. We could take that and plug it into this relationship that we see here and say, well, the increase was $618.10. The original number was $2,472. And then what's now going to be the price on December 31st, 2020. We can similarly attack it as a decrease. B, and it's Dave Downer, analyst at Your Investments, projects that Aurora Cannabis will drop by 12% from its current June 2nd, 2020. I cannot do a good Eeyore imitation, however. So it's going to drop from its current, June 2nd, 2020 price of $19.58 and by, again, the end of 2020. Okay. So again, the amount of decrease, the 12%. 12% based on what? Based on the original or the old number. Right? And that will equal to $2.35. If I want to figure out how much the stock price for Aurora's is forecasted or projected to be, I'd go 1958 minus the $2.35 because it's a decrease, and I would get the forecasted price of $17 and a little bit of change. So again, very intuitive, nothing painful in all this. Okay, this question I will